This is lesson 7.5 in trigonometry applications of vectors, the last section of chapter 5. 2 more chapters to go and we're done with the book. The first thing we're going to do here is look at what is called the equilibrant. And what that is it is the opposite vector. So if we've got vector v here, so we've got this pushing at 60, let me get a red. We've got this pushing at 60, this pushing at 48, or pulling, or whatever, giving us this resultant right here. Okay? Now, so this object, if it's sitting here, if it's a wagon or whatever, with this force and this force pulling on it, it's going to move in this direction with that much magnitude or that much force. Well, if we want to pull in the opposite direction with enough force that this thing does not move, then this is the equilibrant. Okay? Now, this here is going to equal the magnitude of this, only it's the opposite, so it's going to have a negative here. So, if we are looking at example 1, and example 1 says, let's see if I can get rid of my ink here. Example 1 says that we've got forces of 48 newtons and 50 newtons. We're also told that this angle here is 50 degrees. And they want us to find the angle between the equilibrant and the 48 force. So they're looking for this angle here. They're looking for alpha. Okay? So, let's see how we can go ahead and do that. First of all, in order to find this angle, we first of all need to know how long, or the magnitude of v. Because to find this angle, we're going to have to first of all find this angle here. Not the 50, but this angle right here. If we can find this angle, then we can subtract it from 180 and get this angle. So we have to find the magnitude because eventually we're going to use the law of sines in order to find this angle right here. So in order to find this magnitude, we're going to use the law of cosines. So my absolute value of v is going to equal 48 squared plus 60 squared, because that's this right here. And then we're going to add 2 times that 48 times 60. And then we're going to take the cosine of 130. And that will give me a v, or a magnitude then, of 98. So this is going to be 98 right there. So that was very helpful because now we have that magnitude there, and now that we're given that magnitude, I can use my law of sines in order to find this angle right here that I am looking for. So if you remember from 7.1, the law of sines, we're going to take 98 over its opposite, sine of 130, and that's going to equal 60 over this angle right here that we're looking for. And we'll just call it angle CAB, because we've got CAB, so that angle right there. Alright, so we do our math and we find out that that angle is a 28 degree angle right here, which means 180 minus 28 is going to be 152. So this angle here is 152. So, see, not too terrible. Okay, so this next one is having to do with a wagon. And what does it say? The wagon weighs 50 pounds. One of the things that I want you to notice here is that the weight of the object is a downward force, always straight down toward the center of the earth. So we're always going to have our weight, 50 pounds in this, as our magnitude, which is going to be straight down. Okay, and then one of the things you want to do, well, let's finish reading what it says. We want to find the force. We want to find the force it takes to hold that wagon in place, so it doesn't go this way and it doesn't go up. It just is stopped. So this angle here is 20 degrees. It gives you that to the horizontal. So that's what this angle is 20 degrees. And if we look at this here and we go down 50, we can make that into a triangle that's exactly the same as this triangle. So if that's 20, that's 20. If this is right, then that's right. If this is 50, then that is 50. So what we're trying to do is figure out the force that we have to pull on this wagon to hold it still. So it weighs 50 pounds, it's wanting to slide this way, and we're trying to figure out how much force it's going to take to go that way. So we're finding BF, the magnitude of BF, which is going to be the same as the magnitude of AC. So we have this triangle right here with a 20-degree angle, a 90, and then this one obviously is going to be a 70. We know that's 50, and we're trying to find AC. So given the information that we have as far as finding these triangles, it shouldn't be too incredibly difficult. We can go all the way back to chapter 2 and realize that the sine of 20 degrees is going to be opposite over hypotenuse, which in this case the opposite one is going to be what we're looking for, the absolute value of AC, the magnitude, over hypotenuse, 50. So we're going to take 50 sine of 20, so we multiplied that, put that over here, and that is going to be the magnitude of AC. So you just take the sine of 20, multiply it by 50, and you get approximately 17. And that's it. So the key thing here isn't the math, it's the figuring out what in the world they're wanting you to do. Okay, so I'm going to go with a new video. We're going to do 2 more examples and then be done.